Kubernetes for Humans.
So, hello everyone, and welcome back to another episode of Kubernetes for Human podcast. I'm ETL Schwartz, and today with me in the show we have Adrian. Adrian, can you please introduce yourself?
Hi there, Adrian Cockcroft, and great to be here. And I'll now introduce myself. I've got a long career, too much to discuss, and I retired out of AWS about a year and a half ago, so I'm more consulting, advisory, doing a little bit of that kind of thing, and I'm sort of semi-retired. That's my current role.
Yeah, I will say in a second, let's jump into like your background and how did you start it. But I will say like you worked at Sun, at eBay, at Netflix, at AWS, board member for like the CNCF. So overall, like a quite rich and interesting career. So how did it start? Like what, how, why?
Well, right at the beginning.
Let's do the beginning and then like jump to the interesting point.
Yeah. So my father was programming computers in the 1960s. He was a statistician and was working at a local university in the 70s. My school had a link to that. So when I was in high school in the 1970s, I started programming. I ended up doing a physics and electronics degree, building a little control system, a little robot. That's my project, and ended up at a consulting company building engineering real-time things. Then we bought a bunch of Sun workstations, and I was using them. I was sort of administering them as well. I call that early DevOps. I was one day a week sysadmin, developer 4 days a week. And then I joined Sun in 1988 in the UK, spent 6 years in the field, and then moved to corporate in California, and another almost a decade in corporate and various parts of engineering and product marketing, performance team in particular. I wrote a book that a lot of people have on Solaris performance tuning or Sun performance tuning. So I became a distinguished engineer at Sun because people had all read the book. The other DEs had read the book. That was how I became a DE, I think. I said, okay, so writing down what you know is a good career hack, basically. It
sounds like hardcore,
Yeah. Yeah, and then Sun in 2004 was shrinking, laid off large divisions, including division I was in. So I went to eBay for a few years. I'd spent some time with eBay helping them stay up when they were in their hyper growth phase. And worked with eBay Research Labs, did a few interesting things, then went to Netflix for 7 years, initially on personalization, and then the cloud migration from about 2010 onwards for a few years. And then went to Battery Ventures. So we were mentioning before the call, before recording started, that we visited Israel a few times to visit Battery Ventures and some of the portfolio. They have a big office there. And joined AWS in 2016 to help build an open source and community engagement team. And one of the first things we did was write an internal document to say, hey, we should join CNCF and deal with all of this Kubernetes stuff directly rather than sort of dancing around it and trying to figure out what to do about it. With Arun Gupta, who is still deeply involved in CNCF. Between the two of us, we wrote it and got it. I was a VP, so you take it up to management. There's a way of getting stuff done at Amazon, right? They have to write a PRFEQ and walk it all the way up to Andy Jassy, and we got that done. And then I was the original board member for AWS for CNCF, and with Arun sort of as the secondary, and then we flipped that around, put Arun in charge of it, and eventually I moved on to sustainability related things, and Arun left to, I think he joined Apple and then Intel. So he's sort of, there's a whole bunch of people floating around the industry that were in this open source team that I built at Amazon for a while.
I'll be happy, you did more after this, but let's talk a bit for a second about this, because I think it's a very interesting point. Like AWS, were quite notoriously, at least in the early days, not really like an open source like advocate, right? Like you have the people who love open source, you have the companies that don't really. For example, Microsoft did like a very big transition from like a super closed source, we hate open source, to like a night for open source. But AWS never really liked like open source, or at least, as a user, that was always the feeling. There was no big sponsorship. There was no love for any open source project, pretty much. And like, to the contrary, in some ways, it's more around like, how can we utilize open source to make more money? Which, I don't mind, but it is what it is. But, you say that you guys joined the CNCF and you start embracing Kubernetes. So maybe share a bit about, like, why did it happen? And also, how did you convince the folks in AWS? Like, again, it's not really part of the DNA, or maybe correct me, right? I'm seeing things only from far, not from inside.
I think that was the position when I joined AWS. The position was they had a team that was there to make sure open source was used correctly and the licensing was done right. There was no budget for sponsoring things, all that kind of stuff. So the team I put together had a budget to engage with the communities. So the budget I had paid for KubeCon, OSCon, All Things Open, FOSDEM, things like that. So we started turning up at conferences consistently with a team that put together a proper engagement there. We created the AWS Open Twitter handle, the blog, started putting stuff out regularly, basically started engaging and providing people that somebody to talk to. And then, so outbound, we were creating the presence, created the website, got the GitHub organized, all that kind of stuff. So that happened in 2017. We started right at the end of 2016, but during 2017, hired the team and got that going, and just started turning up and engaging with people and convincing internal teams to open source things better. So when they said, "Oh, we're going to open source something," we would get engaged and say, "Okay, this is the right way to do it. This is the people. This isn't ready yet. You need to write this. Whatever." We did put a sort of quality control on the things that were being released, but also the positioning. There was a number of open source based companies that were kind of grumpy with AWS, so we spent some time trying to smooth those feathers down a bit, or whatever, trying to make it a bit better. There's a blog post about Elastic that's got my name on it that was written by a very large number of people to get all the words and everybody, one of those corporate emails, but it went out under my name, about when Elastic didn't really want AWS contributing to Elastic. So the problem with Elastic was an interesting one, because they were upset that we were contributing, not that we weren't contributing. And we were trying to contribute things that made the product better. But in the meantime, we were taking some of the features that they had in their enterprise product and putting them in open source, because we needed security. So we added security to the open source Elastic, and they got grumpy about that. So that was the kind of bone of contention there. And then, eventually I think the relationship with Elastic is a lot better now. Some of the people on both sides have changed, and it's a better relationship. So I think what we did was we dug AWS out of a fairly negative perception hole and moved it to a place where it's general. The open source community sort of knows how to deal with AWS, and I don't think they're really seen as leading in open source, but they're not. They have got significant contributions in several decent places, and there is a team there you can go talk to. Dave Nally is the current guy that runs that team. In his spare time, he's chair of the Apache Foundation. He does that as well. So, we're supporting foundations and things like that. We also, we upgraded the amount we pay to Apache and Linux Foundation and things like that as well. So that was what I did for about 4 years, I think, sort of gradually getting open source to be something that AWS engaged with in a much better way. And I think we had a good outcome in general on that.
I like, two interesting parts. Like, it's interesting what you say about Elastic and AWS that are like now in a better place, because there was all of this like very big license change, right, by Elastic that was mainly designed to fight like AWS. So it's interesting that you say that it's like better now. So good for
Well, I think the business relationship is generally better. The open source companies hopefully have figured out how to leverage cloud providers to build their business rather than seeing them as direct competition. I think what happened in the early days was that there was a good business in the data center and the cloud was small and they just didn't care about cloud. And then so the cloud providers built products. Then as the focus shifted to cloud, the open source companies, they couldn't just sell you the software. They had to figure out how to run a service.
Yeah.
So you see in particular, Mongo with Atlas have had a very successful product that they've built that runs on AWS. And have figured out a way to leverage AWS as a marketing channel and things like that. So that's kind of what I mean by sort of working through the system. But there was definitely a transition period where there was a lot of fuss in the press and people sort of pointing fingers and getting grumpy. And we were just like funding all the open source teams and projects and trying to sort of clarify things where we could and make it into a better place. So I think that worked out well enough, as well as it could be. But in the end, with Elastic, there's now OpenSearch. I think AWS calls it. They basically in the end had forked the project and are investing in that, and that's what you can do. That's the point of open source, right? Yeah. We've seen that more recently with Terraform, where it got basically relicensed, and now there's an open source.
Yeah, open source, which I think like the CNCF like endorse. I understand this from like the vendor side and also the community itself. Like in the end of the day, AWS is the biggest player in cloud by far, and I understand the interest from the open source side. How was it inside AWS? Like, why the transition? Like I understand everyone from the outside, but inside internally in AWS, what happened that it happened? Like they did change the perspective, and they brought you. Right? Is it something in the management that was like open source is a big thing that we're missing? Like, if you can share a bit about that.
Yeah. So in 2016, they basically decided they needed to do something. And I'd run the Netflix open source program. And as I was joining, I didn't join to run this thing. I joined to do a bunch of different things. But they said, would you take on running open source and figuring out how to solve for this problem? So that was a task I took on and a team I built to go do that. That was from a recognition. So they funded it, they funded me, they funded headcount and some budget to pay for all these conferences, whatever, the order of $1 million a year worth of marketing budget to fund conferences and things like that. So that was kind of the level of investment, which is a reasonable amount to get something done. And about 8 people, I think, I ended up hiring. So that was the investment, and then we had the results of a good result out of that. But that was from just in general the open source. So different teams across AWS, some were very much into open source, others weren't, and so it was very different. AWS is not one thing. Every service team is its own little world in some respects. So you have to kind of work across them one at a time and engage with them all differently. So that takes a while to get something done like that. But that worked out, and I think it was overall a reasonable outcome. They're still open sourcing projects quite well, and they're contributing things back to the things that they use and depend on. And there's things like Bubble Rocket and Firecracker that have been quite useful.
Mm-hmm. Yeah, I agree.
And then Carpenter, I think, is the latest one that's kind of been an interesting one and I think that was, I've not been involved in that at all, but as I understand it, it kind of takes over the autoscaler function, but in a way that sort of cuts into two different previous projects that weren't individually fixing it.
I think Carpenter is the biggest success in AWS, like open source strategy, or at least, I'll be honest, all I do is like Kubernetes, right? But from the Kubernetes perspective, it did really shifted the way of doing autoscaling at Kubernetes. It's like a really good project, which is, it's fun to see. and then it is gaining a lot of momentum and a lot of popularity across everyone pretty much.
And then the Kubernetes team, the EKS team, basically hired a bunch of committers like the Etcd and other things like that. So, part of the investment is to hire key people and fund them to do the work and to contribute. So that's the other side of it from an engineering point of view. You have to have people that are giving back to the projects. And I'd say some teams do that better than others across AWS. But I stopped dealing with that around 2020. So I'm a little out of date of what's going on inside AWS from a open source point of view. I focused more on sustainability for 2021 and 2022, and then I retired. And for the last year and a half, I've been independent, sort of watching from the outside, really.
Let's talk a bit about platform engineering, because I know that you have a lot of different thoughts about it. So, maybe share a bit your background around platform in like different companies that you work, and also what are your thoughts? Like, is platform engineering the new DevOps? Is DevOps dead? Is everyone doing platform engineering right? Let's talk a bit about that.
Yeah. So there was about a year ago, there was quite a lot of fuss around platform engineering as a term. And I think that came from a few different things. It's an old concept. People have built platforms for a long time. I think there were two things that brought it to prominence. One was sort of that Kubernetes is complicated, so you need a team to just focus on fixing it. And there were vendors operating saying, we've got a product that is a platform engineering product. So I think that caused some sort of marketing activity around solving that problem for people. So that's one. And then the other is there's a book called Team Topologies, which talked about platform teams as a kind of a team. And I think what that did was it basically gave us a definition for what a platform team was, which was a very useful definition. So it was a combination of those two things that brought it up to be a thing people were talking about, whereas it's something that's been done for decades. Really, it's not anything new as a technique, but I think it sort of crystallized around the ideas and the need and the sort of go-to-market sort of tooling issues. So that's where I think it came from. Does that make sense for your point of view?
No, I think so. I think so. But yeah.
And I did a blog post a year or so ago that we can link to in the show notes. And I basically set out some principles. And the first one it isn't one platform, it's layers of platforms. There's multiple platforms. So if you look at a large organization, you're going to have multiple platform teams, each specialized in different areas. And then that was the first principle. And the second principle is that the platforms evolve and they typically move up the stack. So they gain higher and higher level capabilities, and then they sort of lose lower level capabilities to some other platform that's underneath them. So when we were building Netflix, for example, we built a platform over AWS, but AWS was adding functionality pretty rapidly at that time. And we kept moving things down, like we had a security part of our platform that we moved into AWS because they finally came out with the security models we needed and things like that. So the platform shouldn't be seen as a fixed thing. It should be seen as something that's like a fairly thin layer that's moving up the stack as it adds features. Does that respond to what you're saying?
I'm not sure. Like, what do you mean, like going up how up the stack can you go? Like, in the end of the day, I have a platform team, all right? Let's say that I'm a big organization, couple thousands of developers. I don't know, my platform team is like 20 people, whatever. What do you think when you say like moving up the stack? What is the ideal state? Like, what is like an ideal platform team? Or how?
So if you're using a platform, you always want it to do more, right? You've always said, well, I want the platform to do this for me, and this. Anything you're doing over and over again on top of a platform will probably end up in the platform, right? Or anything that's complicated and hard to figure out, you say, well, let's code that up and put it in the platform with an API that makes it easy to use. So it's basically the platform is an abstraction that makes a thing easier to use, whatever's underneath easier to use. And over time, you'll find out ways to push things into the platform, the commonality, right? So that's kind of what I mean by platforms growing functionality. The thing that is less well understood, I think, is that beneath that platform, there's another platform which is also growing functionality. And if you don't adopt it, then you end up with that multiple independent ways to do things underneath the platform. Things get confusing, right? So there's all these different types of autoscalers. We were talking about Carpenter.
Yeah.
So you've got some higher level platform that you're using. Migrating that platform to Carpenter means that you then stop using whatever, your previous autoscalers, or you're moving your service mesh from whatever, Linkerd to Istio or something, or Cilium or whatever. You've got choices in your platform. Your platform at a higher level picks one of those and says, this is the platform we're going to use. Maybe you abstract a little bit into your tooling, so you don't have to think about it so much. But underneath, at some point you say, we're going to move from, say, Istio to Cilium, just because that seems like a thing. It has some feature we want, something like that. So that's what I mean by the platform changing its underlying capabilities and growing up. But the way you're trying to do it is your build system should automate and have templates and patterns that a developer that just turns up to build something doesn't have to learn in great detail about all of these features. That's kind of what the platform's for.
Yeah, that makes sense. So what are platform teams doing wrong? What do you think is the biggest sin, I will say, of modern platform engineers, if any, right? Maybe.
I think there's a difference between an in-house platform and a platform you buy, because the incentives are different. An in-house platform, you want to be as simple as possible and as easy to maintain as possible. So it tends to be fairly thin. If you're selling a platform, you want to capture as much value as possible. So the platform tends to get thicker and contain more and more stuff. And you try to crowd out the other platform layers in the stack by extending, you've got adjacent layers saying, we're building this layer, but there's another layer here. Well, we can add that functionality to our platform. So you tend to see commercial platforms getting thicker and thicker. And then the other thing that's different in-house to commercial is commercial platforms are sold to lots of people, and they need to be very stable. So their APIs tend to have a high stability guarantee.
Yeah.
Otherwise, you lose your customers when you do an upgrade, and you don't really know who your customers are. You know some of them, but you can't find every user of your platform typically. Whereas internally, you know who's using the platform, right? It's only used internally. There's 4 teams that depend on it or whatever it was, and you can go find the code and you can have a chat to them and say, we're retiring this old thing. Let's schedule the work to get off it, that kind of stuff. So what that means is that internal platforms are more nimble and more able and don't need to maintain the same API. Right? They don't need as much backward compatibility. I mean, it's nice to have, and the bigger a company you have, you might have a platform team on the other side of the company that lots of people depend on. But it's still, if it's in-house, you can still say, okay, get everyone in a room and say, right, we really need to do something to this platform and have everyone move in lockstep to migrate. Whereas once you've built a product that you're selling externally, you're much more locked into stability guarantees. So I think you should very clearly distinguish between in-house and external. And you should think, do I want to have an in-house platform, or do I want to buy an external one, right? Because you're getting something that's maybe more stable and got more investment in it because of its customer base, but it's going to be less nimble if you want to migrate and iterate on top of it. So I'd say platforms work well once they've stabilized and the rate of change has dropped in whatever you're trying to do.
Oh, that makes sense. Do you think Kubernetes as a technology changed something around platform, or how platform is being done, or not really?
Kubernetes itself provided a venue where lots of different pieces of the platform can be submitted, and it's got the nice sort of stability progression, right? You can have something that people just use along with Kubernetes, and most people start using it, and then it can be incubating, which means you're actually trying to stabilize it, and then it becomes, I forget what the final stage is, where it becomes part of the core Kubernetes sort of CNCF projects, right? At that point, there's this sense with open source projects where you say, to go fast, go alone, to go far, go together. And they say it's an African proverb, and there's the history of it. You can go look it up if you like. But the idea being that if you make all the decisions, you can change stuff and you can move very quickly. But the more people you involve, the slower you're going to move, but the more weight you're going to carry with you. And there's typically this point in the life of an open source project where you want to say, okay, this is stabilized enough that what I really need now is adoption rather than new features. And I need to switch over to, so you basically would go to a community like CNCF or Apache or something like that and incubate the project. You give up copyright to the name typically, and you sort of get committers from outside. And now you've got a project which is, rather than just being controlled by one company or one person, is much broader. And those tend to stick around longer and get more investment. But, the rate of change is more painful, right? You've got more people involved, more opinions to keep in touch with. So they tend to be the interfaces tend to slow down and be more stable over time. So I think that's kind of the way to think about it, from sort of the different layers and the different kinds of the way you think about a platform.
I think that makes sense. So maybe let's talk a bit about the future. Like, where is platform engineering going, or like what is the interesting trends that you are seeing? And I know like sustainability is one of them, right? Yeah. But in general, like, share with me the future of platform and the future, like, or interesting trends that you see in the industry.
Yeah, staying on platforms, a lot of the investment now is around AI systems and deep learning systems, and they're big, expensive machines. The individual, like an AWS instance, the latest instance for this is like $100 an hour, whereas most of the instances you typically run on will be like $1 or a couple of dollars an hour, or a few cents an hour for some nodes in a Kubernetes cluster. Now you've got these enormously powerful GPU systems that are very expensive. So you want to be very careful how you manage them. So one of the things I'm looking at right now is sort of the operations management and efficient use of these big number crunching systems, both for training, where you typically have a large cluster of them, and for inference, where they're used a bit more individually. So that's a area of interest, and it's moving very fast. And that tends to be hard for enterprises to deal with in particular. Anything moving fast is going to be hard for them to. So if you thought Kubernetes was going too fast, then you've got a bad time coming, right? Because this is moving far faster than anything that's happened before. So that's interesting. And then there's various uses of AI, machine learning, and LLMs to try and help you write code, help you debug what's going on, various use cases for making it easier to manage development operations and different things. So that's sort of a secondary place where I've been sort of paying attention to a few things. So that's kind of the right now what's going on. A lot of money going into that because these systems are expensive and people are jumping on the bandwagon to go and see what they can build that's relevant to their business with AI. And then at the same time, there's been a bigger need for sustainability, and these are very power-hungry machines. So we need to be very careful about where you get your power from, where you locate systems, and how you measure and optimize for sustainability. So there's the Green Software Foundation. That's an organization I'm part of, and I lead a real-time cloud project there where we're trying to gather together all the metrics from the different cloud providers and come up with proposals for how we should unify those metrics, and then go back to the individual cloud providers to say, okay, can you tweak what you generate to match this schema and these models, so that we start to get the same data from each cloud provider on the same metrics, so that we can build tooling that we can use to optimize the energy that we use for computing and the carbon footprint of our workloads. And the interesting project there is Kepler, Kubernetes efficient power exporter, something. I forget what the R is. But anyway, it's Kepler is really interesting because when you take a workload on Kubernetes, you've got the underlying nodes, which have a certain amount of power dissipation that you can kind of guess at. But then you've got all these pods coming and going, and you have namespaces. So you have a particular workload, and what Kepler does is say, this is a workload, it's a namespace with some things in it, and this workload, I can basically do the allocation of those resources to that workload. So I can figure out a carbon footprint for a specific workload, and multiple workloads on a Kubernetes sharing a cluster, you can basically do the attribution allocation work. And that's an interesting problem to solve for. The other thing they've done is build some simple AI models that basically predict the energy use of a system when they don't have direct access to that data. So for cloud-based systems, you don't have direct access to the power metrics, but when you're running on-premise, you do. So they're building models on-prem, and they're using those models to infer the power in the cloud. So and it's eBPF based, and there's some nice technology underneath it. So I think that's a really cool project.
What is like the main motivation behind all of it? Is it people care? Is it countries that fine you on like carbon emission? Or is it simply to save money because everyone wants to save money? What would you say like the biggest? Why would someone care, right?
I mean, it's coming at you from all directions. So people do care, and employees are very motivated to do something, particularly people who have young children that come home from school and say, hey, what's the world going to be like in 20 years? What am I going to grow up into? What are you doing about it, right? So that is a personal motivator, which shouldn't be underestimated. It's a very strong one. Then top down, your board is having to do audit reports for financial data. Now they're having to add carbon footprint data to those reports. That's becoming mandatory in the EU and in the parts of the US. And so if it's a mandatory report that has to be audited, then from board level, management level, usually coming down through the CFO, maybe operations side, but the CFO has to do a report, and they'll come to the CIO and say, what's the carbon footprint of our compute? Along with, and they'll go to the COO, what's the carbon footprint of our distribution or our whatever you manufacture or whatever you do in that company, right? So it's coming down as regulatory directives which are driving companies to have to report. And then so that's sort of top down and bottom up. And then the other way is to think of is the supply chain. When you go to market, your customers want to buy something that if they see this is green and that one isn't, they'll buy the green option. You see this in the grocery store, right? You can buy the green version, or it's labeling, but there should be something behind it. And there's some rules about how you can figure out how to label something that is more climate friendly versus not. So you want to be able to market your products as greener than the competition if they are, or figure out what that means. And then your supply chain, you need to tell people what the carbon footprint of your products are as they go down. And then when you buy things, you need to know what the carbon footprint of those things are. So when you buy a computer, it has a carbon footprint for manufacturing. The silicon which really dominates. The silicon is the number one piece in manufacturing, which means SSDs, solid state disks, are very high in carbon from the manufacturing side. CPUs are a bit less, memory is a bit less. And then the packaging and the shipping and all that stuff counts to a little bit, but it's mostly the silicon. And the silicon is currently made in parts of the world that have very high carbon in Asia. And so as we decarbonize Taiwan and Korea and Japan and China, that actually helps that, but that's going to take another decade or two to get to. Whereas in the US and Europe in particular, you can buy green energy relatively easily. It's available. You can do some contracts to say, I'm going to get 100% green energy. You just have to pick a supplier or build a wind farm or a solar farm or something, depending on how big you are. And most of the energy use now, particularly in the US and Europe, in cloud providers, is already, they've already got enough green energy, renewable energy, or at least carbon-free energy. But in Asia is still where it's difficult. Singapore doesn't have enough land area to lay out lots of solar, and they've got too much shipping for offshore wind. I'm not sure. It's challenging in some parts of the world to get a lot of green energy. And that's kind of where we are right now with the various cloud providers.
Okay, Adrian, super interesting. Like really, like and like I love the taking on like you explaining the green motivation, I would say. Anything else that you want to add up before we wrap it up? Because we kind of need to.
Yeah. I think that's probably most of it. If anyone interested in sustainability, the Green Software Foundation is quite active. They're producing some standards. If you're interested in cloud, the real-time cloud things I do are all publicly available. It's all on GitHub, so you can go find it there. And I'm hoping to be at the NVIDIA conference in a week or two to find out what's going on a bit more in the AI, LLM space, all the training machines and things like that. So there's a bunch of interesting hardware that's coming out right now that's very powerful, that's quite interesting. So that's pretty much what I'm doing. And I'm, like I said, I do a bit of advisory, a bit of consulting. That's generally and then most of the time I'm being retired and running around having fun. So that's kind of, it's nice to not be running a team and a company and a website and keeping everything running. So people can look forward to the day when they retire from corporate life and just go live off something else. And I was luckily I did well enough out of Netflix and Amazon to fund being retired. So that's pretty much it.
Like, working at like Sun, eBay, Netflix, and AWS can't really hurt like your retirement plan. And with that, thanks very much, Adrian, for being like great guest in the show. And if you are in NVIDIA like conference in like 2 weeks, search for Adrian. And I'm also going to be in KubeCon in a week. Adrian, I guess you are not coming there, or no, it's in Paris. No, it's far. So thanks a lot, and goodbye, everyone.
Okay, thank you. Bye.
Kubernetes for humans.